going to change the structure of pentane, taking note that the molecular formula must remain the same. So this is the structure of pentane now, and that is the structure of the isomer of pentane. So this structure is referred to as neopentane. So that is the neopentane, whereby we have one central carbon atom surrounded by 4 carbon atoms, and then in the 4 carbon atoms we equally distribute the hydrogen atoms. So the carbon atoms in the neopentane are 5, and the hydrogen atoms, as you can count, they are exactly 12. That is an isomer of pentane. So remember, these are compounds. So these are compounds having the same molecular formula but different structural formula. So that is an isomer. So let's go to the next question, whereby this question is asking, dry hydrogen chloride gas, which is HCl gas, was dissolved in water, as you can see. So dry HCl gas was dissolved in water, as you can see. So the question is asking, the first question is asking, what was the use of the inverted funnel? So why was the inverted funnel used, as you can see? So the inverted funnel was used, first of all, in order to provide a large surface area over which the hydrogen chloride gas was going to dissolve in water. So that's the first answer. So the second answer will say that the inverted funnel was used in order to prevent the sucking back of water, a very high tendency to dissolve in water. Now, due to this high tendency to dissolve in water, it is going to suck the water in order to dissolve the water. And finally, what will happen is that we will notice that the HCl gas, if we are not using the funnel, we'll notice that the water rather will be sucked from the trough and onto the source of the HCl gas. Why? Because the HCl gas is very soluble, therefore it will pull the water in order to dissolve the water at a given force. Now, the answer here is the second answer. So the second answer is that we are using the inverted funnel in order to prevent the sucking back of water from the trough and onto the source of the HCl. So that's the second reason why we are using an inverted funnel. So remember, the first reason we say that to provide a large surface area over which the HCl will dissolve in water, and then the second one is that the inverted funnel is used in order to prevent the sucking back of water from the beaker onto the source of the HCl where it's coming from. So the second question, which is B, we are being asked, state the observations that were made on the litmus paper, because we see that we have a litmus paper. So the litmus paper, we are being told that it is blue litmus paper. So what will happen is that the blue litmus paper is going to change to red color. So why will the blue litmus paper change to red? So the blue litmus paper will change to red because the HCl gas is an acidic gas. Now, this HCl gas, as it dissolves in water, it produces hydrogen ions, whereby the hydrogen ions are responsible for changing the blue litmus paper to red in color. So in Form 1, we differentiated between an acid and a base. And an acid, we say that these are substances which dissolve in water to produce hydrogen ions. Whereas for base, we defined a base as these are substances which dissolve in water to produce hydroxyl ions. Now, since here we have hydrogen chloride gas, we see that the hydrogen chloride is going to dissolve in water to produce hydrogen ions. Now, these hydrogen ions are the ones responsible for changing the blue litmus paper to red, indicating that the solution that has been formed is acidic. So the next question is asking, state the observations that will have been made if methyl benzene was to be used instead of water. Now, if methyl benzene was used instead of water, the litmus paper wouldn't have changed any color. So the litmus paper will still remain to be blue in color. But what is the reason? So the reason is it's because we see that methyl benzene does not have any charges. Now, since it doesn't have any charges, it's not going to ionize the HCl or the hydrogen chloride gas. So since it's unable to ionize the hydrogen chloride gas, we see that in turn, the hydrogen chloride will not anyhow react with the blue litmus paper to indicate any color change. And for us to use the methyl benzene, finally we see that the blue litmus paper is going to still remain to be blue in color. Why? Because methyl benzene is non-polarized. It doesn't have any charges. And since it doesn't have any charges, again, it's not going to ionize the hydrogen chloride gas, which is responsible to give an indication of the litmus paper if the solution or the gas is basic or acidic. Now let's question whereby we are being asked, using sodium hydroxide, explain how you can be able to differentiate between copper 2 ions and iron 2 ions. So using sodium hydroxide, that's the chemical that we have been provided with. So the first step, we are going to dissolve the sodium hydroxide in copper 2 ions, and then finally we dissolve the sodium hydroxide to iron 2 ions. Then we make an observation of the color change. Now, as you can see here, we see that if we dissolve sodium hydroxide in copper 2 ions, we are going to get copper 2 hydroxide, which is a blue precipitate, and sodium in aqueous form. So the next experiment, we see that if we dissolve sodium hydroxide in iron 2 ions, we are going to get iron 2 hydroxide plus sodium in aqueous form. Now the iron 2 hydroxide is a green precipitate. So remember the first one, the copper 2 hydroxide is a blue precipitate, and the iron 2 hydroxide is a green precipitate. And now getting back to a question we are being asked, using sodium hydroxide, explain how you can be able to differentiate between copper 2 ions and the iron 2 ions. So this is how you can be able to differentiate, by observing the color change. So the copper 2 ions is going to give us a blue precipitate, and the iron 2 ions is going to give us a green precipitate. So maybe we can rephrase the question and ask, explain how you can be able to test iron 3 ions. So instead of using iron 2 ions, what if the question was asking iron 3 ions? So if we dissolve sodium hydroxide in iron 3 ions, we are going to get iron 3 hydroxide plus sodium in aqueous form. Now iron 3 hydroxide is brown in color. So remember, we say that copper 2 hydroxide is blue in color, iron 2 hydroxide is green in color, it gives a green precipitate rather, and then iron 3 gives us a brown precipitate. And that's how you can be able to differentiate them using sodium hydroxide. Now the last question is asking, below is a laboratory preparation of chlorine gas. So study the chart and answer the question that follows. So the first question you are being asked, name W and Y. So name W and Y in the chart that you can see. So we see that W reacts with manganese 4 oxide. So W reacts with manganese 4 oxide, and then we get chlorine gas, which is moving from the first chamber to the next chamber, whereby we have a chamber containing water molecules. And then from the water we go to the next chamber, whereby it is labeled as Y, and then from Y we collect dry chlorine gas. So the first question is asking, name W and Y. So in the laboratory preparation of chlorine gas, what reacts with manganese 4 oxide to form chlorine? It is automatically hydrogen chloride acid. Rather, it is hydrochloric acid. So HCl reacts with manganese 4 oxide to form chlorine gas. So as you can see, this is the chemical reaction whereby the manganese 4 oxide reacts with the hydrochloric acid, whereby we are going to react 1 molecules of manganese 4 oxide reacting with 4 molecules of hydrochloric acid. We are going to get 1 molecule of manganese chloride plus 2 molecules of water, and then 1 molecule of chlorine. Now this chlorine is in gaseous state, and looking at the chart we see that this formed chlorine now moves to the next chamber, whereby we have water molecules. So what is the function of water? Why must chlorine pass through water? So the chlorine must pass through water in order to absorb all the HCl, or the hydrogen chloride gas fumes. So all the hydrogen chloride gas fumes must be absorbed. But where is the hydrogen chloride gas fumes coming from? So remember, in the first chamber we used heat. So we heated the solution, or we heated the components in order to speed up the rate of reaction. Now, in speeding up the rate of reaction, we see that some of the hydrogen chloride gases escaped from the first chamber and onto the next chamber whereby we have water. Now, there again comes the function of water. So the function of water in this experiment is to absorb all the hydrogen chloride gas fumes that were produced. So remember, in the previous number, we saw that we can use we saw that the hydrogen chloride is very soluble in water. Now, since hydrogen chloride is very soluble in water, it's going to dissolve very quickly in water. Now, getting back to this experiment, we see that we have water there in order to absorb all the hydrogen chloride gas fumes that are going to be formed in the first part of the experiment. Now, from the water chamber, we go to the next chamber, whereby it